Hi and welcome to video 5 on this video series on Unit 4 Topic 1 Financial Mathematics from the Year 12 General Math course in Queensland. And we're going to talk here about time period considerations because it's important to recognise that if you shorten the time period on a compound interest investment, you actually do better because you're getting more regular banking of your interest, and therefore you're getting more opportunities to earn interest on your interest. Now, as you shorten it, you'll find that it does still get better, but it becomes less better over time. So it's quite significant early on when you go from yearly to monthly or monthly to weekly, but then as you go from days to minutes or something like that, it really doesn't make that much of a difference. Let's have a look. First of all, the nominal interest rate is the quoted annual rate. So you'll almost always be given a quoted annual rate. You'll be told your investment earns you 10% per annum. But you may need to adjust the rate to suit a different compounding year. There's no effect on a simple interest, and I'm just going to tell you that as a statement. There's no effect on a simple interest. You can investigate why if you'd like to, but essentially what happens is if we go from a yearly amount to a monthly amount, we get the principal will stay the same. The interest rate will be I over 100 as a decimal, but we have to divide that by 12 to work out the monthly interest rate, and n will be the number of years, but we now have to multiply that by 12 to work out the number of months. And so if you do I is equal to PIN, you get P times I over 100 divided by 12 times n times 12, and the 12s cancel out. So because simple interest is arithmetic and linear, they cancel out quite nicely. Compound interest, it doesn't cancel out, and it does have an effect. Let's have a look at an example. Bobby could also invest his savings, so this is a follow-on from the last video, of $1,800 at 3.4% per annum for 5 years compounding yearly or weekly. So I'm just going to shoot up here, and we'll grab this solution that we got for Bobby investing yearly. And so this was part 2, so that was our solution for the yearly investment. And we'll copy that, and we'll just paste that here so we've got that. Now, option 3, because we still have the simple interest one in play a little bit, is a weekly one. So in a weekly one, we go back to that planning. A equals P 1 plus I to the power of n. And our planning says that the principal is equal to 1,800 and the interest rate is equal to 3.4 over 100. I'm doing the conversion now into decimal. And the number of years is 5. But it's 5 times 52 because we're doing this weekly. And our interest rate is 3.4 divided by 100 divided by 52. Now, I'm going to just stick with fractions. That means I don't lose value, because if I do 3.4 divided by 52 and divided by 100, I get 0.00065384615, and I'm pretty sure that continues on. That means I have to round at some point. What I'm going to do is leave it as 3.4 over 5,200, which is not ideal because there's a decimal in my numerator, so I could say 34 over 52,000. And again, that can be simplified, but really this is not a huge problem. I would be sticking with that value there, 3.4 over 5200, and n is 5 times 52, which is 260. And now we can just substitute those values in. A is equal to P, we haven't changed the investment, times 1 plus 3.4 over 5200 to the power of n, which is 260. I've not lost any value because I've kept that as a fraction, and so my rounding is fine. 1,800 times by 1 plus 3.4 over 5,200, close brackets, to the power of 260, which seems quite large, but your bit inside the fraction will be quite small, and that's equal to 2,133.43. Now, our simple interest, 1, was $2,000 133. Let's just do some highlighting. That's the first answer, second answer, third answer. It turns out if we go from yearly to weekly, it actually bumps our compound interest up above the simple interest amount. And remember, the simple interest, it's not better, it just had a higher rate, 3.7, whereas these two are operating at 3.4 and 3.4. Now you might say, and probably rightly so, that we are grappling around for a difference of basically $6. But ultimately you might be dealing with more money, and this shows you that compound interest works better, and compound interest with shorter compounding periods is even better yet again. And now time for some light-hearted entertainment.
The more important invention than the first telephone. The second one.
There's a couple of important things here. We have semi-annually or biannually is a half a year. We've also got these important ones. There is 1 year in a year. There are 4 quarters in a year. There are 12 months in a year. There are 26 fortnights in a year, 52 weeks in a year, and 365 days in a year. You will not need to deal with leap years unless you are told to deal with leap years. You can deal with everything else in the way it is. You can make the assumption that all the months are equally length, unless again you are told it's in the month of April, which has 31 days. So unless you're specifically told. How many weeks in a month? And the answer is not 4. So the answer is actually that if there are 12 months in a year and 52 weeks in a year, then there are 52 weeks in 12 months. And we divide that through. We want to know how many weeks in a month. So we divide it through by 12, and it's 52 over 12 weeks. In 1 month, which is what the question was, 52 over 12 is actually equal to 4.3 repeater. There are 4 1/3 weeks per month in a year. So just be careful of that mistake of saying there's only 4 weeks in a month, which is not necessarily true, even though we've got some rounding considerations and some variable month amounts here. So here's our can you list, which is our success criteria for this lesson, and a link to what you need to know to complete exercise 7B. All the best.